Okay, so still on question 3. Now we fuse in, you said question 2B from the quiz.
Yes.
Okay. So 2B, this was quiz 2? Yes. Okay. So x minus 3 plus 1 greater or equal to x plus 4. And so you want to see how you can solve this. Now this one is got so many ways of going about this question. The first one, let's attempt to square and see what happens. So what I mean here is I'm squaring here, I'm squaring there. So I'll get x minus 3 plus 2 x minus 3 plus 1 must greater or equal to x plus 4. So the x goes, this x follows that x, and then we take negative 3 the other side, it becomes 1. We take 1 the other side, it becomes 4. So we have 2x minus 3 greater or equal to 3, that side becomes 7, then minus 1. So we have this greater or equal to 6, divide by 2. So we have this greater or equal to 3. Then we square, we have this greater or equal to 9, this greater or equal to 12. Now when you get that, you test if it makes sense in there. So pick 12, take where it is x there, and then add a 1. You will get 9 plus 1, which is 3, plus 1, which is 4. You leave it there, pick a 12, take it to the right hand side. You will get 4. In there, so you have 16, which is 4. So the greater or equal to, the equal to has worked. Can you pick another number and check if it will hold there? So you say, okay, let me pick a number greater than 12. What about a number less than 12? Suppose we picked 7. 7 minus 3 plus 1. This is 4 plus 1, which is 2 plus 1, which is 3. Then 7 plus 4, which is what? Which is 11. And the square root of 9 is 3, meaning that the square root of 11 is bigger than 3. So it does not work for numbers less than 12. And so we can end here as our solution. Alternatively, when checking here, if you found that something worked and it's outside what you have found here, you go back and pick x minus 3, equate it to 0, and pick x is equal to 3 as your critical point. You also get x plus 4 is equal to 0, and say x is equal to negative 4 is a critical point. And then solve also for a value from this, x minus 3 plus 1 is equal to x plus 4. So as you are squaring here, you are solving for the equal to part. So you say, I want, so when you square here, you square there. So you know this one will lead us to x is equal to 12. And then you form a table using this. So if I can use this space, you form a table using this. So there's -4, there's 3, there's 12. So you pick a number here, say 13. You pick a number here, say 5. You pick a number here, say 0. You pick a number on the left, say -5. And then start testing now in this whole equation. So you bring -5 here. This will not be defined. So you cancel that. That region is out. You bring 0 here. This won't be defined. Out. You bring 5. Okay. It's defined, but does it hold? So you say 5 minus 3, that will be √2, plus 1. Is it greater or equal to 5 plus 4? That is 9. This is 3. But the square root of 2 is somewhere 1 point something. Plus 1, it will be 2 point something, which is not greater or equal to that. So you cancel out that part. You bring 13 in here. So 13 there is defined, and to give you 13 minus 3, you get 10. Plus 1. Okay, at least you know the square root of 9 is 3, so this is 3 point something. Plus 1, it must be 4 point something. Get 13 and bring in here. You have 13 plus 4. That will be √17. Now the square root of 16 is 4. Square root 17 is 4 point something. So it makes sense that they must be greater or equal to that thing there. And that's how you pick that region. And because we have greater or equal to, you pick starting from 12 to infinity. So you include the 12. So meaning that you have now solved fully. So you could use that approach, the table approach, or this one. Sometimes the direct one of squaring, sometimes it considers a bit because it may leave out some parts. That's why you go and test first. The table one is testing direct, so there's no need of testing after you have verified that. After you've picked that, that's your answer.
Sir.
Hello.
Hello?
Hello.
So even if there's a slight difference, you just assume they are equal to.
We haven't said they are equal. We've said it is greater or equal to. Because what happens is, because 13 is not a perfect square, right? I mean 17 and 10, we approximate using 9 and 16. So since you have greater or equal to, you come and test on the 12. You test on the 12. So 12 minus 3 plus 1. That is √9 plus 1. This is 3 plus 1, which is 4. The other side, 12 plus 4. You get 16. And that is 4. So the equal to part has worked. So it makes sense then afterwards. That's why we're picking that. So if it was still greater, and then you find that they are equal, then you do that at 12.
Oh, sir.
Hello?
But how do you find 12 when
What do you mean? How?
you don't square, sir? Because found it. Because you said when you
Wisdom.
when you just use the squaring part, you may reach point 12 without squaring.
Mm-mm.
Mm.
I didn't say that. What I said is, alternatively, if you don't want to use this method, you use the longer method where you make the inside, that one, equate it to 0. You also get x plus 4 equated to 0 and you get this. Then you go back to the whole thing and remove the inequality there, the greater or equal. You put the equal sign and solve by squaring and get 12. Now you have three numbers which you are using as your critical points. And that's how you obtain the 12. That's why we call it the longer method.
Thank you, sir.
All right. Am I allowed now to go back to the past paper and continue with question 3? Question 3C now. One, solve the following inequalities. 5 over x minus 2 greater than 2 over x plus 1. The first thing you do here is this. You don't cross multiply at this point. And then get the common denominator. So you have 5 x plus 1 minus 2 x minus 2. And then 5x plus 5 minus 2x plus 4 over x minus 2 x plus 1. Then 5, you get 3x plus 9 over x minus 2 x plus 1 greater than 0. Now somewhere in the marking key, I saw something that was a bit fun, like there where they just cross multiply the denominator goes and remain with 3x plus 9 greater than 0, so that x should be greater than negative 9 over 3. So x must be greater than negative 3. Now I don't use this, I don't trust this. Now let's test. So we get the critical points at this stage. X is equal to negative 3. In the numerator, x is equal to 2 and x is equal to negative 1. So we have negative 3, negative 1, 2. After 2, we get 3. After, yeah, this one does not work. So after negative 1, we get 0. Here we get negative 2. Here we get negative 4. This one we forget about it. It cannot work. I think I didn't see properly. Then we have 3x plus 9. And then we have x minus 2 Then we have x plus 1. And then we'll have 3x plus 9 over x minus 2 and x plus 1. And then we have this. Okay. When this is negative 4 here, what do we get? We get negative 12 plus 9, which is minus. Negative 4 in here, minus. Negative 4 here, minus. Everything when you multiply, minus. Negative 2 there, you get negative 6 plus 9, positive. Negative 2 minus 2, negative. Negative 2 plus 1, negative. Product, positive. 0 plus, minus, plus, minus. Plus, 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 plus. What do you want? Where it is greater than 0. So the solution set is going to be negative 3 all the way up to negative 1 union 2 up to infinity. That's how you get the solution set. And this question looks like it was there somewhere. Was that a quiz? There's something identical to this solution. Okay. Any questions here? We're going to see 2. Okay. C2, the modulus of x minus 2 over x plus 1 is less or equal to 3. By definition, this implies that negative 3 is less than x minus 2, x plus 1, which is less than 3. That's the reason why we say when you're finding validity, you find something like this, you can as well write it as that, because that's how you find the modulus. It's from that definition. Then you now get pieces there. So you say I have negative 3 less or equal to x minus 2 over x plus 1. And I have x minus 2, x plus 1 less or equal to 3. So this is the first piece. This is the second piece. So the first piece, this is the same as having negative 3. For the easiest, it's the same as having 0 less or equal to x minus 2 over x plus 1 plus 3. So that you say 0 is less or equal to x plus 1 down, x minus 2 minus 3x plus 3x plus 3. So you have 0 is less or equal to 4x plus 1 over x plus 1. For this part, your critical values are x is equal to negative 1, x is equal to negative 1 over 4. That is negative 1, negative 1 over 4. You pick a 0 after, You put a negative 2 before. In between, you add these two numbers. What do you get? You get negative 5 over 4, then divide it by 2. So you get negative 5 over 8. Negative 5 over 8 as the number in between. Then you pick your 4x plus 1, x plus 1, and then the 4x plus 1 over x plus 1. Test negative 2 here, you get negative. Negative 2 here, negative. Plus. Then there will be negative. Then there will be plus. For fulfillment's sake, if you want, you can test. There. Is it true? Yes. 4 negative 5 over 8 plus 1. That is 2 here. So you get negative 5 plus 2 over 2, which is negative, positive, positive, positive. So for this part, you get the solution set to be 0 is less or equal to mean that it is positive, greater or equal to 0. So you get negative infinity all the way up to negative 1. Oh, you don't include negative 1 because it's in the denominator. So you do that. Union, you include negative 1 over 4 all the way up to infinity. We're done with one piece. We go to the other piece where you say so this piece here, you say x minus 2, x plus 1 minus 3 less or equal to 0. So you have x plus 1. So you have x minus 2 minus 3x minus 3 less or equal to 0. So that negative 2x minus 5 over this guy. So the critical values, you get x is equal to negative 5 over 2 and x is negative 1. So you have negative 5 over 2. You also have negative 1. The number in between is negative 2. And then you have 0. You have negative 3. And then you have negative 2x minus 5, x plus 1, negative 2x minus 5 over x plus 1. You have this, that, this, that. Moves. Okay, then you test now. Negative 3 here, positive, negative, negative. Here, minus, minus, positive, minus. Like that. So the solution set here is, you want to write is less or equal to 0. So you get negative infinity up negative 5 over 2 included union negative 1 up to infinity. Then you get the intersection. So you can call this solution set 2, solution set 1. Now you get solution set 1 intersection solution set 2, which is negative infinite to negative 1 union negative 1 over 4 to negative infinite. Intersection negative infinite comma negative 5 over 2 union negative 1 comma infinite. So what becomes our solution here? So to get the intersection of intervals, you go in this first interval and that first interval. Pick the smallest number on the left. You have negative infinite. Okay. Between negative 1 and negative 5 over 2, you pick there you pick the smallest. In between this and that, what do you pick? Between negative infinite and negative infinite, you pick the largest. Yes. And then between negative 1 and negative 5 over 2, you pick the smallest. So that here we pick negative 5 over 2. It's included. Union. Between negative 1 over 4 and negative 1, you pick the largest. So it will be negative 1 over 4. In between negative infinite and infinite, you pick the smallest. I mean positive infinite and infinite. Remember, this is positive. So we have infinity. This is our intersection. So if you get confused, you can as well use intervals. I mean, use number line where you draw and break your numbers. So here, negative 5 over 2, negative 1, negative 1 over 4. The other interval starts from here, going to the left, actually including. The other one starts from negative 1, open, going to the left. The other one starts from negative here, going this side. The other one also from here, going left side. And you're getting the intersection. So you get the intersection, this piece, and also this piece. Which will lead you to negative infinite, to negative 5 over 2, included, excluded, union. This one includes that part. So included 1 over 4 negative infinite. Like that. So everything is okay. Okay. Oh,
Hello?
I'm getting. Is that a question?
Yeah.
Mm-hmm.
I
Sir,
Hmm?
sir.
Hmm?
Yeah, so my question is, how do you know that it is included? Like, negative 5 over 2 is included and the negative 1 over 4 is included. How do you know that it's included?
From the question. When there is less or equal to, you include the numerators. When there is less or greater, you leave out both. The denominators are never included.
Okay, sir. I've seen it.
Okay, so again, we log out and log back. We still have time. Let's do that quickly so it don't take time to start. We're now going straight to question 4.